How many number of 7 digits can be formed with the digits 1, 2, 3, 4, 3, 2, 1? We are given 7 digits here, and also we want a 7-digit number, and it is that all odd digits are 1, 3, 3 and 1. We want these odd digits to occupy odd positions and the remaining 3 even digits to occupy even positions. That is, we have to permute this 1, 3, 3, 1 in these 4 places, which we can do that in 4 numbers permuted among themselves in 4 factorial ways, of which 2 1s are identical, divide by 2 factorial, and 2 3s are identical, divide by 2 factorial. And even digits, which are 2, 4 and 2, they can be permuted in 3 factorial ways. Among these, 2 2s are identical, we have to divide by 2 factorial. So this would be our final answer. 4 factorial is 24, by 2 into 2 into 2, 8 is 3, 3 into 6 is 18. So we can do that in 18 ways. Let us look at the next question. How many words can be made with the letters of the word technology which do not begin with T but end with Y? The word should end with Y, but it should not begin with T. Let us do this question in 2 ways. Technology is a 10-letter word. Our last place is always Y. So put Y here and freeze it. Now, remaining 9 places can be filled with 9 letters in 9 factorial ways. But identify that there are 2 O's which are identical. So we have to divide by 2 factorial. In this, there will also be cases where T is in the first place. We need to remove those cases where T is in the first place. T should not be the first letter. So how many letters will be there with T as first letter and Y as last letter? T in the first place, Y in the last place, and remaining 8 letters can be permuted among themselves in 8 factorial ways, of which 2 O's are identical, so divide by 2 factorial. So answer is going to be 8 factorial by 2 factorial can be taken common. 9 minus 1 is 8. 8 by 2 is 4. 4 into 8 factorial. On simplification, this comes out to 161280. Another way in which the same question can be done is, I want a 10-letter word. Last digit is Y. First place cannot be T. So first place can be dealt in 2 ways. Either you put a O here, or you will put a letter which is other than O and T. Other than O and T, Y is also already used, so cannot be used again in the first place. 4 options are ruled out. We are left with 6 options for the first place. It could be E, C, H, N, L, G. And we are putting Y in the last place. And remaining 8 places can be filled in 8 factorial by 2 factorial ways. 2 factorial is because 2 O's are identical. And when you are putting O in the first place, you have 8 digits to permute in the 8 places. You can do that in 8 factorial ways, and no 2 of them are identical. So our answer is going to be 8 factorial plus 6 by 2 is 3. 3 into 8 factorial, or 4 into 8 factorial, which comes out to 161280. Let us look at next question. How many words can be made with the letters of the word institution such that vowels and consonants alternate? Vowels and consonants alternate. Let us look at what all vowels are there. We have 3 I's, 1 O and 1 U, and consonants are 6 N, 2 N's, 1 S and 3 T's. Now vowels and consonants, we want them to alternate. It is possible in only one way. First having a consonant, then a vowel, then consonant, vowel, consonant, vowel and ending with a consonant. 6 consonants and 5 vowels can be made to alternate in this fashion. So for 6 positions of consonants, we have 6 letters and we can permute them in 6 factorial by 2 n's are identical 2 factorial and 3 t's are identical 3 factorial ways. And for vowels, we have 5 vowels and 5 positions. We can permute them in 5 factorial ways, of which 3 i's are identical. We have to divide by 3 factorial. So effectively our answer is going to be 6 factorial by 6, 5 factorial by 2, 60 into 5 factorial by 3 factorial, 120 by 6, 20, which is 1200. In how many ways can 6 boys and 6 girls be arranged in a row so that no 2 boys and no 2 girls are together? Question is, we need to arrange 6 boys and 6 girls in a row such that no 2 boys and no 2 girls are identical. Let's say boys are these blue triangles. We have 6 boys. Let us arrange them. And no 2 girls are to be together. So girls, let's say they are these red triangles. They are also 6 in number. Now they should come alternate. No 2 girls are together and no 2 boys are together. Now for this last girl, there are 2 positions. Either the series can start with a boy or it can start with a girl. So there are 2 ways in which we can permute them. The alternate series of boy and girl starting with a boy, or alternate series of boy and girl starting with a girl. So we can decide this in 2 ways. And once we have made the decision in 2 ways, now 6 boys in these 6 blue places, they can be arranged in 6 factorial ways, and 6 girls in 6 red places can be arranged in 6 factorial ways. So our answer is going to be 6 factorial into 6 factorial into 2, which will be 1036800. How many words can be made with the letters of the word Bharati so that all vowels are consecutive? All vowels are consecutive. What all vowels are there? A and I. We have 3 vowels here, and B, H, R, T are the 4 consonants. Now you want all vowels to be consecutive, you want them to be together, pack them. Now You have 4 objects to permute. One, the packet containing the vowels. Second is B, H, R, T. So you have 5 things to be permitted among themselves. You can do that in 5 factorial ways. And inside the packet, I, these 3 letters, can be permitted among themselves in 3 factorial by 2 A's are identical, so 2 factorial. So answer would be 5 factorial 120 into 3, 360. Next question. How many number of 6 digits can be made by arranging the digits of the number 1, 2, 3, 4, 2, 5 so that all the even digits do not occupy consecutive places? All the even digits do not occupy consecutive places. How many even digits are there? 1, 2 and 3. 2, 4 and 2. There are 3 even digits, and we have to permute them so that all the even digits do not occupy consecutive places. So 2 of the 3 can occupy consecutive places, but not all of them can occupy consecutive places. So for this question, find total number of permutations. Total number of permutations of 6 digits are 6 factorial by 2 2's are identical, 2 factorial minus. From this we need to remove those cases in which all even digits are together. How many cases will be there where all even digits are together? Put all even digits together, 2, 2, 4, and odd digits are 1, 3, 5. Now 3 digits and 1 packet. I have 4 things to permute among themselves. I can permute them in 4 factorial ways, and within the packet 2, 2, 4 can be arranged in 3 factorial by 2 identical to 2 factorial. So answer would be 6 factorial by 2 factorial 360 minus 4 factorial into 3 factorial by 2 factorial 72, which gives you 288. In how many ways can the letters of the word algebra be arranged without changing the relative orders of vowels and consonants? Without changing the relative order of vowels and relative order of consonants. In the word algebra, if you look at the order of vowels, A is the first letter, then comes E, and then comes A. And if you look at the consonants, first is L, G, then B, then R. So we should not disturb the order of the vowels, relative order of the vowels. First it should be A wherever it is, and then should be E, and then should be A. And when you are looking at only consonants, first should be L, then G, then B, then R. That in a sense says A can be permuted among themselves in only one way. L, G, B, R can be permuted among themselves in only one way. Whenever 4 objects can be permuted among themselves in only one way, we can treat them to be identical. And similarly, A, if they can be permuted in only one way, we can again treat these 3 objects to be identical. So we have 7 things to permute among themselves. We can do that in 7 factorial ways, of which 4 consonants are identical, their relative order cannot be changed, and 3 vowels are identical. So answer will be 7 factorial divided by 4 factorial into 3 factorial, which will be 72. Next question. Find the number of ways in which 10 candidates in an examination can be ranked if two particular candidates are always next to each other. Let's say those two candidates are A and B. A and B always want to be together. We can pack them. Remaining 8 candidates, and this packet can be permuted in 9 factorial ways. And inside the packet, A and B can be permuted among themselves in 2 factorial ways. So effectively this permutation can be done in 9 factorial into 2 factorial, which is 760 ways. For the next question, if one particular candidate, let's say he is given to be C, is always above another particular candidate, let's say D. That means when you are arranging in the merit list, C is always before D. C and D can be arranged among themselves in only one way. C is always before D. So you can treat C and D to be identical, 10 persons to be permitted among themselves in 10 factorial ways, of which C and D are identical, divide by 2 factorial. So answer would be 10 factorial by 2 factorial, which will come out to 1814400. In how many ways can the letters of the word cinema be arranged so that order of the vowels do not change? What are the vowels there? I, E and A. C, N, M are the consonants. Now, the order of the vowels do not change. We can treat all 3 vowels to be identical. They can be permitted in only one way. Their order cannot be changed. So have 6 things to permit among themselves in 6 factorial ways, of which 3 vowels are identical, divide by 3 factorial. So answer should be 6 factorial by 3 factorial, which is 120. A dictionary is made of words that can be made by arranging the letters of the word parkar. What is position of the word parkar in the dictionary? If words are printed in the same order as that of an ordinary dictionary. So in an ordinary dictionary, we know words are listed in alphabetical order. Letter starts with A, and then you will have letters with K, then P, and then we have 2 R's. So before, by permuting these 6 letters among themselves, first you will have all letters starting with A. Starting with A, how many letters would be there? Arranging the remaining 5 letters in 5 factorial ways, of which 2 R's are identical, 2 factorial ways. Then comes letters with K. When you put K in first place, remaining 5 places can be arranged in 5 factorial ways by 2 factorial. 2 A's are identical and 2 R's are identical. So letters starting with A will be 60 in number, and letters starting with K will be 30 in number. Then comes letter starting with P, and we also want a letter starting with P. Immediately for the second place, the preferred letter would be A. We also want it to be A. Then word starts with another A, third letter A. With this, how many 6-digit letters will be there? Permute the remaining letters R, K, R in 3 places in 3 factorial by 2 factorial ways. R, K, R, 2 R's are identical. We can do this in 3 ways. Then after P, A comes P, A, K. Starting with P, A, K, The remaining 3 letters we can arrange them in 3 factorial by 2 factorial ways. 2 R's are identical. We will have another 3 letters. Then comes PAR, that is what we want, and next preferred letter would be A. So how many letters will be starting with para? Remaining 2 places can be permuted by R and K in 2 factorial ways. 2 letters. And then comes PAR, preferred position would be after A, K, A and R. This is the word which we are interested in. So before getting the word of our interest, we have 60 plus 30, 90 plus 8, 98 words. So rank would be 98 plus our word 1, 99 rank.